equations. So a literal equation is a mathematical equation that just has more than one variable. So typically before, like in 1b, we would solve an equation that would only have one variable. So kind of thinking back to 1b, we're going to solve these equations. So we want to solve for the indicated variable. So in this case, we want to solve for x. So in order to solve for x, we want to do the order of operations backwards. So this is called inverse operations. So we want to go backwards. So we're looking in regards to x. So in regards to x, we're doing 3 times x. So we have multiplication. And then here we have x minus 12. So we also have subtraction. So if we're going in order, we have to take care of subtraction first. So we have to get rid of that 12. So we're going to do our inverse operations. So the opposite of subtracting 12, we want to add 12. So what I'm going to do is I'm going to add 12 to both sides. You have to think of it in terms of like a counterbalance. What you do to one side, you have to do to the other. So when I add these 12s here, they're going to zero out. So all you're left with is 3x equals 24 plus 12, which gives you 36. So now your next step, now we want to get rid of that multiplication that's happening. So in order to get rid of multiplication, we're going to do the inverse. So we're going to divide. So I'm going to divide by 3. So when I divide by 3, you get x equals 12. So taking a look at the second one, this one's a little bit more involved. So in this case, we have that 3 halves on the outside of the parentheses, and we want to solve for h. So what I'm going to do is I'm going to distribute that 3 halves. So I need to distribute it to everything inside the parentheses. So I'm going to have 3 halves times 4h and 3 halves times 6. And that's going to equal 9. So I'm going to clean this up a little bit. So what I'm going to do is I'm going to multiply the numerator times the number on the outside. So 3 times 4, which gives me 12. So that's going to be my new numerator over 2. Don't change the denominator. That stays the same. So now I'm going to do the same thing. So the numerator times the outside, so 3 times 6, which gives you 18 over 2 equals 9. So now I'm going to further simplify it. So 12 over 2 simplifies to 6. Then 18 over 2, which is 18 divided by 2, which gives you 9. That equals 9. So I'm going to take that same exact equation. Now I want to solve for h. So what I'm going to do is I'm going to subtract 9 on both sides. So you have 6h equals 0. And now I want to divide both sides by 6. So if I divide both sides by 6, if you have 0 divided by 6, that just gives you 0. So we're going to be doing essentially the same thing. However, instead of one variable, now our equations are going to have 2 variables or more. So now we're looking at literal equations. So each one of these equations is going to tell you what we call an indicated variable. An indicated variable is what they tell you to solve for. So in this case, x is my indicated variable. I want to get x by itself. So what I want at the very end, I need an x equals equation and just whatever's on the other side. So I'm still going to follow my inverse operations. It's still the same procedures. So in this case, I have x minus 6 equals y. I need to get x by itself, which means I have this minus 6 right here that I have to get rid of. So the opposite of subtracting 6 is going to be adding 6. So I'm going to have x equals. Now on the right side, we're going to have y and a positive 6. we can't actually combine those into one value, so we leave them separate. So I just write y plus 6. So that's all we have. That's our equation. So let's take a look at the next one. So our indicated variable in this case is a. So I need to get a by itself. So on this side of the equation, I have c times a. If there's no operation, you assume they're being multiplied. So in order to get rid of that c value, I need to divide both sides by c, because you want to get rid of it. So in this case, I'm going to have g over c equals a. So a is by itself, so I'm going to kind of switch it up. You want your variable on the left side. So I'm going to have a equals g over c. Okay, so I suggest you actually pause and try the next two on your own. All right, so for this one, we are solving for x. So I need to get rid of this 4 down here in the bottom. So what this is saying over here is I have x divided by 4. So the opposite of division is going to be multiplication. So I'm going to multiply both sides by 4. So when I multiply, this 4 and this 4 simplify. They simplify to 1. So I have x equals 4y. All right, so this next one, we want to solve for n. So n is our indicated variable. So I need to get rid of this m on this side. So there's no sign in front of m, so I'm going to assume it's positive. If there's no sign in front, you assume it's positive. So because it's positive, to get rid of it, I'm going to subtract it on both sides. So I'm going to have negative n equals p minus m. Now notice we still have this negative out in front. That negative we've got to get rid of. So I can think of it as a negative 1 times n. So what I'm going to do is, because I'm multiplying times that negative 1, I'm going to divide everything by a negative 1. So now, two negatives when they divide make a positive equals p minus m over negative 1. So I'm going to simplify this a little bit more. So I'm going to have n equals p over negative 1, and then I'm going to have negative m over negative 1. So now I just want to kind of clean it up. So p over negative 1 is just going to be a negative p, and a negative m over a negative 1 gives you a positive m. So you could technically keep going. So in this case, we just switch them up. So it'd be m minus p. Mathematically, we don't like to start with a negative unless we absolutely have to. So technically, this is what your answer would be. However, this answer could also be accepted as well if it was an answer choice. All right, so next one. So we're solving for y. So still going to follow your inverse operations. So I need to get rid of any addition and subtraction first. So that means I got to get rid of this 3x first. So because it's positive, I'm going to subtract it. So I have 4y equals negative 3x plus 18. So there's no sign in front of the 18, so you assume it's positive. Now I'm going to divide both sides by 4. Okay, so in this case, we're going to have y equals negative 3x plus 18 over 4. So typically you could stop here if your problem cannot be simplified anymore. However, because this problem can be simplified further, we have to keep going. So in this case, kind of think of it this way. 3 over 4, that cannot be simplified. However, 18 over 4, that can be simplified. That's what tells you to keep going. So I'm going to separate it. So I'm going to have y equals negative 3 over 4x plus 18 over 4. So I'm going to simplify that fraction. So y equals negative 3/4 x plus 9 over 2. So we cannot simplify it any further, so that would be it. All right, next one, now we're solving for x. So in this case, we have to get rid of any addition and subtraction first. So remember, this is being multiplied. This right here is being subtracted. So because this part's being subtracted, that's what I have to get rid of first. So I'm going to add 3y to both sides. So I'm going to have negative 2x equals 3y plus 1. Now I want to divide. I want to get rid of that negative 2. So I'm going to divide by negative 2. So I'm going to have x equals 3y plus 1 over negative 2. All right, so because of that negative, we technically have to simplify more. So what I'm going to do is I'm going to have x equals 3 over negative 2y plus 1 over a negative 2. So really all we have to do here is just move the negatives around. So in this case, we're just going to have x equals negative 3 over 2y minus 1 over 2. So here, all we do is we move the negative to the numerator, which that's just mathematical notation. You don't typically want to have it in the denominator. And then over here, we had a plus a negative, which just turns into subtraction. So it's just some small things that we had to clean up. All right, next. So now we want to solve for x. So in this case, it's a little bit more tricky now that the indicated variable is in the denominator. It just adds a couple extra steps. So I still want to get rid of that denominator value, so I'm going to multiply both sides by x. So when I multiply, they simplify, so those are gone. So I have m equals p times x. So you don't have to write the sign in the middle. You could just write px. Either is fine. So I still need to get x by itself, so I got to get rid of this p value. That p value has to go away. So because it's being multiplied, I'm going to divide both sides by p. So these will simplify. So I have m over p equals x. So now I just want to flip it around because I want my variable on the left side. So x equals m over p. All right, so I would actually suggest you try this one on your own. So just pause for a minute or two, or however long you need. All right, so we're solving for a. So I'm going to add b on both sides. So I'm going to have g plus b equals ca. So I still want to get a by itself. So I need to get rid of the c. So in order to get rid of c, I'm going to divide. So I'm dividing because they are multiplying. So I'm going to have g plus b over c. And that equals a. So once again, just like before, just want to flip it around. because I want my variable on the left side. So A equals G plus B over C. So these are some pretty standard literal equations that you could see. So the questions on the back, these are the ones that are going to be a little bit more challenging. So this is going to be where the indicated variable actually appears in more than one spot. So this is going to be bringing in kind of the reverse distribution, which is called factoring, which we actually cover factoring in a later unit, more in depth. So in this case, I want to solve for m, but notice how m is in two different places. So in this case, you want to get m to one side. So the key here is to get the indicated variable on one side of the equal sign. So you want to be able to do it in as few steps as possible. So if I move this m over here, then all the m's would be on the same side and nothing else would be there. However, if I move this m to this side, we would still have this negative 5n on the same side. So that's not going to be the best move for us. So we want to go with the first option. So I want to move the 4m. So I'm going to leave negative 5n equals, and I'm just going to write it exactly how it looks. We can't combine these. So I just have mp minus 4m. So this is the step that's going to kind of make this a little bit more challenging. So notice how we have an m in both terms. So instead of distributing, I actually want to do the opposite. I actually want to take it out. So I'm not going to change the left side. However, I want to take out that m. So if I take it out, I'm going to open up some parentheses. So if I take the m away from both terms, look to see what you have left. And the first, if I take away that m, I just have p. If I take away the m here, you have minus 4. So we just did the distributive property backwards. So if I actually redistribute it, you should get what we had up here originally. Okay, so now notice the m is only in one place. Now we're good to go to solve it. So this is two separate terms. We have m and we have p minus 4. So because of those parentheses, you have to think of it as one single term. So what I'm going to do is I want to divide by p minus 4. So on the right side, these will simplify. So I have negative 5n over p minus 4 equals m. So we don't have to write the parentheses for p minus 4 on the bottom since there's no other value with it, so we can just leave it how it is. So once again, I'm going to flip it, make sure our variable's on the left side. So m equals negative 5n all over p minus 4. All right, looking at the next one. Now we want to solve for x. So once again, notice how it's in more than one spot. So what I'm going to do is I actually want to get these to the same side. However, if you look, we have 8x and negative 3x. There's not another variable with either of these x's, which means we could actually combine these. So what I'm going to do to combine them is I'm going to move the negative 3x. I'm going to add this over. So these I can combine since we just have the numbers out in front. So you can just do 8 plus 3, so you get 11x minus 5n equals y. So we're still solving for that x value, so we still got to get rid of it, or everything around it. So I'm going to add 5n. So I'm going to have 11x equals 5n plus y, or y plus 5n. The order in this case doesn't really matter. So now I'm going to get rid of that 11. So to get rid of that 11, I'm going to divide. So I'm going to have x equals 5n plus y over 11. So this is where you need to look to see if you could further simplify. So 5 over 11, that does not simplify. Y over 11, that does not simplify. So we are good to stop here. All right, next problem. So now we are looking for x. So I would actually pause here, try this one on your own, a minute or two, or however long you need. Okay, so in this case, now we're going to solve for x. So once again, you want to get the indicated variable on one side. So if I move the 2x over here, then all the x's would be on the same side. But if I move the xg over here, I would still have this 4 that's kind of in the way. So that's not a good move. So I'm going to move over the 2x. So I'm going to subtract 2x. So that leaves us with 4 equals xg minus 2x. So now this is where I'm going to take out that x value just like before. So it happens in two different places. So I have 4 equals, I want to take out that x. So if I take it away from both terms, I have g minus 2 left. So I still need to get rid of that g minus 2. So I'm going to divide. So now these g minus 2's, they simplify on the right side. So I have 4 over g minus 2 equals x. So just want to flip it over. So x equals 4 over g minus 2. All right, now on this one, we're going to solve for u. So I need to get them to the same side. So if you notice, there's nothing in front of the u over here. So I can just pretend there's a 1. There's just one u. So what I'm going to do is I actually want to combine the u's. So I'm going to subtract the u's on both sides, or at least one u. So these u's are gone. So you have 2a equals 3b plus just one u. You don't have to write the 1. So I only have that u that I need to have by itself. So I need to get rid of this 3b. So it is a positive 3b and it's being added. So I'm going to subtract. So I have 2a minus 3b equals u. So once again, I want the variable on the left-hand side. So I'm going to have u equals 2a minus 3b. So this one is a little bit challenging, still doable. So we want to solve for a. So it's actually on two different sides of a fraction bar. So in this case, I need to get rid of this denominator one first. So what I'm going to do is, because it's being divided by Ka, I'm going to multiply both sides by Ka. So when I multiply this Ka and this Ka, they simplify. So I have Ka u equals negative 2a minus 3. So the numerator of that fraction didn't change at all. It's just the denominator that had to change. All right, so now I still need to get all the A's on one side. So I'm going to move this set of A's to the left side. So to do that, I'm going to add 2A. So I have 2A plus KAU equals -3. So once again, the order addition is commutative, so the order doesn't matter. So now I want to take out that A value. So I'm going to take out A. So when I take out that A value, you just want to kind of see what's left. So you have 2 plus KU equals -3. So for our final step, divide by 2 plus KU. So the 2 plus KU, those will simplify. So you have A equals -3 over 2 plus KU. All right, so this one's also kind of challenging. So this is similar to one of the very first problems that we did at the top. So we want to solve for X. So first thing, I'm going to distribute that 2/3 to everything inside the parentheses. So I'm going to have 2/3 times 6x plus 2/3 times 12y. That equals xz. So just like before, multiply the numerator and the whole number. Numerator and the whole number. So 2 times 6 gives you 12 over 3x plus 2 times 12, which gives you 24 over 3. Y equals xz. So now you're going to simplify those fractions. 12 over 3 simplifies to 4x plus 24 over 3 simplifies to 8y equals xz. So we still want to get the x by itself. We need to get the x's on the same side. So what I'm going to do is I'm going to subtract the 4x on both sides. So I have 8y equals xz minus 4x. So once again, I'm going to take out that x value from both. So I have 8y equals x parentheses. So to see what you have left, I'm going to mark out those x's. So I have z minus 4. So now I need to get x by itself, so I'm going to divide by z minus 4. So I have 8y over z minus 4 equals x. So now once again, you want to get the variable on the left side. So you have x equals 8y over z minus 4. So these back ones are a little bit more challenging, but they're still doable. But you're going to see more problems like the front problems. Hopefully that's some good news for you. So literal equations, you are going to see some word problems. So we're just going to do one as an example. And it's still the same process as any others. You just actually have to write out the equation. But in this case, we give you the equation. So the volume of a square pyramid is volume equals 1/3 times the side squared times the height, where V is the volume, S is the side length of the square, and H is the vertical height of the pyramid. And we want to solve the equation for H. So when they tell you what variable to solve for, they're telling you this is the indicated variable. I want you to solve for H. H is what you need to get by itself. So I'm going to rewrite the formula. So V equals 1/3 S squared H. So we need to get h by itself. So I need to get rid of the 1/3 and the s squared. So what I'm going to start with is I'm going to get rid of this 1/3 first. So whenever I have 1/3, this is the same as doing 1 divided by 3. So if I'm doing 1 divided by 3, I'm going to do the opposite, and I'm going to multiply by 3. So when I multiply by 3, the 1/3 and the 3, they simplify to 1. So you have 3v equals s squared times h. So you still need to get that h by itself. So I'm going to divide by s squared. So now these values will simplify. So you have 3v over s squared equals h. So once again, variable on the left. So you're going to have h equals 3v over s squared. So because this is a measurement and it's talking about height, we don't actually have a unit given. So in this case, the height would just be in units. So just to kind of put the bug in your ear, so I'm actually going to do this equation again. But now I'm going to solve for s. So I just want just the side length. So there's a reason I'm going to do this one, and you'll see. So I'm going to start it the same way. So I'm still going to multiply by 3. So I'm going to have 3v equals s squared times h. So the 1/3 and the 3 are gone. So next, I'm going to get rid of that h. So now I'm going to divide by h. So I have 3v over h equals s squared. So now here's the thing. I need to get rid of the squared. So the inverse operation of a squared is actually taking the square root. So I'm going to take the square root of both sides. So I'm going to have the square root of 3v over h equals s. And once again, flip it. So the side length is equal to the square root of 3 times the volume divided by h. This would be units.